There are robots in almost all areas, from factories, services, and commerce. Each day, robots become more important in our society in performing complex tasks. We see the hardware, but robots are not only a physical machine. Robots are complex systems composed by hardware and software, and the software allows the hardware to perform these complex tasks in robotic systems. So, what is the relevance of software in robotic systems? What can happen when software fails in complex systems like robots? Hi, I'm Marcela, and in this video I'm gonna explain my research subject, robotics software engineering. Robotic systems are a complex combination of hardware and software, and there must be an integration between the robotic systems components. What enables the system to perform as expected? The hardware are the sensors, robotic arms, navigation panels. The software layer can be divided into a control system and application layer. The control layer provides a software component that allows communication with the hardware, and the application layer uses the control layer to support robotic operations. My research subject is about the software for robotic systems, more specifically, robotic software engineering. I am to apply software engineering techniques approach to improve software robots. But why is it important? Before we continue, it's important to understand what is fault, fail, and error in software. A fault may remain undetected for a long time until some event activates it and brings the program into an error. Error is a state of system. If nothing corrects the error, it becomes a failure. Finally, when the system does not act conform prescribed in the specification, we have a failure. But what can happen if the software fails in a complex system like robots? We have two cases where the software fails and the consequences are unpredictable. Two flights crash happened due to faulty software in the Boeing 737 MAX, killing hundreds of people. The second case happened with NASA's Curiosity rover, a mobile robot that explores Mars. The robot lost its sense of direction and stopped due to software bug. We understood what can happen if software fails in a complex system. It's time to understand the challenge related to fail, fault, and error in robotic systems. Let's go. One of the main challenges related to robotic system development is reliability. Software reliability is a quality aspect that determines the degree with which a system operates free of failure over a specific time in a given environment for a specific purpose. An important aspect of reliability is a fault tolerance, the degree with which a system operates as intended despite the presence of hardware or software faults. The example showed that undetected system faults can originate failures. In practice, it's difficult to guarantee failure-free software. However, to reduce failures and overcome software reliability challenges, researchers have proposed rigorous development and test process to perform solutions. How can we apply software engineering approach to improve reliability in robotic systems? My research subject is in this room. Our first step was to identify and classify the development of software engineering for robotic systems in a quality software perspective. Two important points from this study. The less investigated software quality aspect is security. Second, software testing is investigated only in 5% of the included study. Now we are performing another mapping more general. Our aim is to identify, classify, and evaluate the software engineering areas used in the robotic domain based on the ASW EBOK guide, a known guideline for software engineering. There are studies that evaluate robotic software engineering. However, this previous study neither addressed software engineering in general for robotic systems nor SW EBOC areas. One of the contributions of this study is identifying research opportunities and gaps in software engineering for robotic systems. The next step of my research is to choose one of these gaps, create a hypothesis, and validate it to defend. But this is another conversation, maybe for another video. In this video, I answer the questions: what are robotic systems? What can happen if software fails in robotic systems? And what is the main challenge in software development for robotic systems? I also presented the progress of my research. Thank you for your time. See you soon.